Hey, also in this video we are going to look at our third and final method for solving quadratics this quarter. We've looked at factoring and we looked at square root principle in the last section, and then this will be quadratic formula. Factoring and square root principle are limited to particular cases, like the equation has to factor to use factoring, and they don't always factor. So, and likewise with the square root principle, it's not always easy, like right here, to isolate that squared. We would still have an x on the other side, so that would be an effective method for solving this one. So the quadratic formula kind of works for anything. That said, in some cases it is much easier to factor. For instance, let's say we had, x squared plus 5x plus 4 equals 0. We could plug all of this in the quadratic formula and do all this work that I'm about to show you, or we can say what multiplies to 4 and adds to 5, x plus 1, x plus 4, and our solutions are going to be -1 and -4. That was much easier than using the quadratic formula, so there's absolutely a place for factoring. Likewise, the ones that I just did in 8.1 in that last video, much easier to square root both sides than to FOIL everything out and then plug it back into here. So there's good places for those techniques, but they don't always work. So this is the technique that if you can get something into that form, it's going to work. You're going to plug it into that formula. Let me get rid of this real quick, and then I'll explain what this is. So basically, if you have ax squared plus bx plus c and you use a technique called completing the square that we're not going to look at this quarter, and it would take me about a full whiteboard worth of math to get there, but if I solve this thing for x, completing the square, I would get this formula. So anytime you have something of this form, you can take the coefficients where a is the coefficient for the x squared, b is the linear coefficient, c is the constant, and you can plug them in for the a's, b's, and c's over here, and that's going to get you your solutions. So not always the easiest way to get there, but it will always get it done, and sometimes it's the only one that works. Pardon the coughing, I'm getting over a cold still here. So one thing with this is we need to be equal to 0, same as when we were factoring. If I have the choice of having a negative leading term or not, I will always pick the or not. I find it kind of annoying when there's a negative on the x squared term. So I would move that over to this side and rewrite this as, it would be positive x squared then, minus 10x minus 3. And so what that means is my a is 8, because that's what's in front of the x squared term. B would be -10, and c is -3. And then we're just going to plug those into this formula and simplify, and we'll have our solutions. So x equals -b, so that would be the negative of -10. You're welcome to just write +10 there, but I want to show you that it's the opposite of whatever b was, so it's going to come out a positive in this case. Sorry. The all-important plus or minus, same as we saw in the last section, that's going to give us our two solutions. B squared, so -10, quantity squared. And careful right there that those parentheses, you should write them. Even if you don't, you should realize that it's -10 times -10, and that this is going to be a positive quantity every time. -4 times a is 8, and c is -3. And all of that, that was a bad line, let's try that again. All of that is over 2 times a, so 2 times 8. And then from here we just have to clean all that mess up. So -10 is just 10, and then plus or minus -10 times -10. So again, that's always going to be a positive value, because even if you're squaring a negative, it's two negatives. And then here I like to just count up my negatives. So if I only had one negative, this would be a minus. If I have two negatives, negative times negative would make positive, it would be a plus. If I had three negatives, it would be subtraction again, a minus. And then that is 32 times 3, which is 96. all over 16. So coming over here, that will be 10 plus or minus 196 over 16. And then if you try, and I would just, before I got worried about simplifying this, I would just see if the square root of 196 is anything good. And if you do that, you will find that it is 14. So this is really 10 plus or minus 14 over 16. So 10 plus 14 over 16, or 10 minus 14 over 16. Okay, so 10 plus 14 would be 24 over 16. And 20 over 16, if I reduce by 8 on both, that would be 3 halves. 10 minus 14, that would be negative 4 over 16. And simplifying 4 out of both of those will leave me negative 1/4. So what that means is this original one, sorry about the coughing, this original one would have factored because it came out to rational solutions. And had you seen that, you could have factored, and you could also use the quadratic formula to solve. So same thing, this one's already in the right form. So I will do, this time it's going to be P equals, there is an invisible 1 right there, so it will be negative 1 plus or minus b squared, so 1 squared minus 4 times a times c all over 2a, so 2 times 2. So p equals negative 1 plus or minus, that will be 1, that double negative is going to be a plus, 8 times 5 would be 40 over 4, and so the answers are negative 1 plus or minus root 41 over 4. And that would be it. The 41 doesn't reduce at all, so nothing further to do there. Okay, for this next one, the directions are saying solve an answer to the nearest hundredth. So in this case, like this last one, I ended up with these two solutions, negative 1 plus root 41 over 4, and then negative 1 minus root 41 over 4. When it mentions that wants the answer to the nearest hundredth, we're going to get an answer like this, which is the exact solution, and then we're going to have to put those in the calculator at the end. So, same thing, we'll have x equals negative of negative, there's an invisible 1 right there, so negative 1 will be 1, plus or minus negative 1 squared minus 4 times a, don't love that negative, which if you don't love this negative, you can multiply both sides by negative 1, and do that with the positive. Since I'm just going to throw this in the calculator, I'm not worrying about it, but you can do that. For a c, so c is 12. That's all over 2a. That's actually why I don't like the negative, is you end up with 1 in the denominator, which just makes it a little harder to type in the calculator. And so then this is going to be 1 minus and minus would be plus. That is 8 times 12, so that would be 96. So that is 97 if you go ahead and clean all that up, should end up with 1 plus 96 there, all over negative 4. So this is actually two distinct answers. This is 1 plus square root of 97 over negative 4, and then also x equals 1 minus square root of 97 all over negative 4. And then to the nearest hundredths, you would then put this in the calculator. And what I would suggest doing, what my calculator is putting in the numerator first. What you can't do is go 1 plus 97 divided by negative 4. You need to have parentheses around the numerator if you're going to do it all in one step. So for me, I usually just do 1 plus square root 97, and I hit equals, and on my calculator I have 10.848 blah 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 showing, and then hit divided by negative 4 as a second step. And that way I don't have to worry about parentheses. If you want to put it in all at once, then be careful to get parentheses around there before you do the divided by. And so if you tap that in right, you should get negative 2.71222, but rounded to two decimal places, negative 2.71. If you do the same on this side, you'll get x equals 2.21. Again, sorry about the coughing. For this one, we're not quite in the right form, so I'm going to go ahead and distribute that p through the parentheses, and I'll get 8 equals, that will be 3p squared, and then times that negative 1 will make minus p, and then I need this to be equal to 0, so I'm just going to scoot over here with it, and have 0 equals 3p squared minus p, and then subtracting the 8 over it, give me a minus 8 right there. And then same thing, this is asking for both the exact solutions and rounded to the nearest hundredth. So we will do p equals negative 1 will be 1 plus or minus negative 1 squared minus 4 times a times c, and that is all over 2 times 3. So sneaking over here with it, we'll have 1 plus or minus, it's going to be 1, the double negative will make that a positive, 12 times 8, 96, so another 97 I think, over 6, or p equals 1 plus or minus square root of 97 over 6. So that's your two exact solutions, 1 plus root 97 over 6, and then 1 minus root 97 over 6. Those are our p equals. And then the rounded to the nearest hundredth, so again, just like the last problem where we put that in the calculator, when I did this, I got, for that first one, I got 1.81, and for that second one, I got negative 1.47. And then this last one is just kind of the same thing. So again, it's asking, give both exact and rounded answers. For this one, we just have to remember we need to FOIL this and then incorporate that negative 1 over. That's the only thing that's different about this, just to get it in that standard form. So foiling, we'll go 4w times w and get 4w squared plus 8w. On the inside, we got minus 5w, and on the end, we got minus 10. And then I'm going to go ahead and add that 1 over to this side, just so I don't have to rewrite all that, equals 0. And then let's collect our like terms. So 4w squared, 8 minus 5, that'll leave us a 3w. Negative 10 plus 1 would leave us a negative 9 right there, equals 0. And then from there we can throw it in the quadratic. So w equals -3 plus or minus 3 squared minus 4 times a times c all over 2a. So that would be -3 plus or minus, that would be a 9. 16 times 9 is 144, and double negative makes positive. All over 8. And then just cleaning that up a little bit more, we get -3 plus or minus 153 over 8. So there's our two exact solutions again. And then putting the plus version and then the minus version in the calculator for my decimals, I got 1.17 and -1.92. Last thing on these, there's a couple of things that we haven't seen happen, and in this class they won't happen, but if you go on to 141, you'll run into these. So these have all behaved really nicely, and we haven't had to reduce this radical. In future classes, you'll get harder equations where this piece will reduce, and you end up having to reduce some fractions. The other thing that we haven't seen happen is we have not gotten a negative number under a radical. That can also happen. So say I had, -3 plus or minus, and I got -7 right there over 8. Next quarter, you're going to learn about complex numbers, and that there's the square root of -1 gets represented as I, and this ends up being a complex number. For this quarter, we will only run into it in the next section, but this doesn't have a real solution, and we'll see that when we do intercepts in the next section. So for 8.2, nope, won't happen. We'll see it briefly in 8.3.